So creating a corridor model is fairly easy to do. We're going to be picking the horizontal, the vertical, and the assembly to use, and the frequency about which we want to model this corridor. To create a corridor, navigate to the Home tab, Create Design Panel, Corridor Tool. We'll give our corridor model a name of Bypass-1, Corridor Style Basic. We'll use the alignment of bypass. And for the profile, notice how it automatically goes to the _vert1 as this is at the top of the alphabetical list. For the assembly, we'll pick the 2-lane with sidewalk, and for the target surface, we'll toggle to Combined EG. Now make sure you also have Set Baseline and Region Parameters toggled on, as we would like to define these before we build the corridor model. If you don't want to set any baseline or region parameters, you could click OK and your corridor model would be built right on the spot. Click OK, and now we can define our baseline and region parameters. Notice how you can edit anything that we just defined in that dialog box. The thing that we want to change is the start station. Let's set this to 300 as this is where our vertical alignment is going to start. For the end station, let's click on the Define Station button, and we'll navigate to the location we want to end this corridor model. We don't want it to go all the way to the end. We want it to go to the end of where our horizontal alignment exists right here. We'll go ahead and snap, and now we've got that end station defined. Let's click on Set All Frequencies, and as you can see here, you can define how often you want it to model. So along tangents, we'll go ahead and go with 15 feet, press Enter. Notice how you have the option to add an increment, by curvature, or both. So notice how you can define by mid-ordinate distance, along spirals, at geometry points, and so on. We'll go ahead and click on Add an Increment, and we'll set this to 5 units. We do want to model at PCs and PTs, and we do want to model along the profile curves at also a distance of 5 feet. We'll go ahead and click OK, and we'll go ahead and click OK to rebuild the corridor. Civil 3D is modeling at those frequencies and at those stations. And here is our corridor model. Pretty simple, pretty straightforward. Civil 3D allows you to target any kind of AutoCAD or Civil 3D object with a subassembly. As long as that subassembly is allowed to target, then you can define that target in the corridor model. Let's go ahead and first select our corridor model, and then navigate to the Modify Region panel and select Edit Targets. What this allows you to do is allows you to select a specific region within a corridor model. We only have one region, so we'll just go ahead and click inside here, and now we're targeting this region. So what we want to target is a sidewalk. We have 2 pylons that we want to target for our inside boulevard width of our sidewalk. One has constraints applied to it, and the other one is just a standard pylon. So this is why you name your subassemblies with something that makes sense. That way you can find them when you start targeting, as the name states exactly what you want to target. We'll click on the inside boulevard width and want to set this to feature lines, survey figures, and polylines. We'll go ahead and click on Select from Drawing. That minimizes, and then we are prompted to select the objects. Now what's really cool is that you can select objects that may not be directly in line with each other. As you can see, I'm selecting 2 pylons that are not connected in any way, shape, or form. What Civil 3D will do is it'll automatically find them based upon the alignment stationing, and it'll just start transitioning that part of the subassembly to that pylon. What's not shown here is you also have the ability to select objects that are in an X reference if you'd like to as well. Let's right-click, and we have those 2 objects selected. Click OK, and now we want to target the right side. So on the right side, what we have for the right lane is we have an offset alignment already defined with a transition in our drawing. Again, the name right lane, we'll go ahead and pick on width alignment, and then we'll pick on the alignments category, and it's right here, bypass 1, right 12 feet. We'll click Add, and now we'll click OK. Click OK to rebuild the model, and you will see automatically Civil 3D will transition to those specific objects. And of course, if you change any of the objects, whether it's the offset alignment or the regular AutoCAD polyline, you'll be notified to rebuild the corridor model, and it'll update automatically. Press Escape to end the targeting functionality. Corridor properties allow you to change many things within the corridor model. You can change things such as the code set style, what feature lines will display, as well as all the regions and parameters. First, select your corridor model, navigate to the Modify Corridor panel, click Corridor Properties. The Corridor Properties dialog box contains 7 tabs. Let's first investigate the Parameters tab. So the Parameters tab allows you to change all the different baselines, frequencies, targeting, regions, alignments, profiles, etc. that are being used within the different parts of your corridor model. You simply click on the different fields and you can change those different locations there. The Codes tab allows you to see what exact codes are being used in your corridor model. So these are the codes coming from the subassemblies. You can also change the code set style to a code set style that you wanted to use for plotting in your plan view. Let's use this one called Visualization, click Apply, and watch what happens after we rebuild the corridor. Notice how all the point, link, and shade codes have disappeared, and all we're left with is our planimetric graphics. So how do you control that? Well, if you navigate to the Feature Lines tab, here's where you can control that. These columns are completely sortable, and these are all the feature lines being created in our corridor model. Don't forget, the feature lines are created from the point codes defined in each of the subassemblies. We'll go ahead and select here. Again, these columns are sortable, and we'll click over here, and let's set our feature style for all of these to a no display feature line style. That way, they will all just be turned off immediately, and then we can go and turn on the ones we want. So first, let's go ahead and select all the curbing type features that we want to plot. Click on back of curb, top of curb, flow line gutter, and I'll go ahead and click on the feature line style column, and we'll change this to a corridor curb line feature line style. Click apply, and as you can see, we're starting to get our features in there. Select all our sidewalk features, so we'll pick the sidewalk in and sidewalk out, and we'll change that feature line style to the corridor curb line as well. Click OK, click apply, and now we'll start to see our sidewalk appear. We can go ahead and pick our daylight and daylight fill. Let's set those to a different feature line style for just the regular daylight fill, and if we had a daylight cut feature in our corridor model, we could set that to a totally different feature line style, allowing you to put it on a different layer with even a custom line type. Lastly, let's select our edge of travel way, and we'll go ahead and put that on its own feature line style, completing the display of our planimetric graphics. We'll discuss the surface and boundaries tab later on, and slope patterns is just there for you to define a slope pattern between two feature lines if you want to display them looking a certain way. You'll most probably not use too many slope patterns. Click OK, and let's look at some other ways that you can actually make changes. With the corridor model still selected, you'll notice these cool looking grips here. If you want to adjust a region, you can simply select the grip here, and you'll notice that it allows you to go right to the station value that you want to. As long as you have dynamic input turned on, you can actually define the station. Let's go to 150, press enter, and the corridor model updates automatically. Civil 3D makes it easy to create a surface once your corridor is created. Zoom into your corridor model and go ahead and select it. Navigate to the Modify Corridor panel, and let's go ahead and click on Corridor Surfaces. So the first thing you want to do is you want to add an entry for your corridor surface. We'll go ahead and click in here once and type in Road 1. You can give it a style if you'd like to, and a render material as well. Now the two types of data that you can add to your surface are basically within the corridor model. You can add feature lines or links. Let's first start with the links. Once you select that data type, Civil 3D interrogates the corridor model and tells you, hey, you have these links that you can add to a surface. For this one, let's make a top surface, so all we want is the top code. This will then add in all the links that have that top code definition defined in them. Click the plus sign, and now we have it. If you want to tighten up your triangulation a little bit, you could add these as a break line as well. And if you want to make sure that you get all the top links, if you are picking the top link code, you would pick top links here. Just like if you were doing a subgrade surface, you would make sure you pick the bottom links as well. Sometimes Civil 3D will not triangulate exactly as it should because the triangulation isn't tight enough based upon the frequency at which you modeled. What you can do is you can actually add in the feature lines, for instance in the curb areas. So I'll add in the back of curb, we'll add in the top of curb, and we'll also add in the flow line gutter. This way it'll tighten up the triangulation through the curved areas of the alignment where there's curb and gutter. Next, let's make sure we add a boundary to the surface. This way it'll get rid of any erroneous triangles as we go around the curves within the alignment. To add a boundary, simply right-click and choose Corridor Extents as Outer Boundary. Note that you can do this interactively if you wanted to pick individual feature lines, or you could do it from a polygon if you wanted to. We'll click Corridor Extents as Outer Boundary, click OK, rebuild the corridor, and there's our surface. Press Escape to clear our selection set, and let's go ahead and select just the surface. Let's take it into the Object Viewer, and as you can see, we have a nice tight surface with all the features that we wanted to display within there. Corridor modeling gets you about 85 to 95% done with your model. Afterwards, you need to use the section editor to review and edit the sections that you might want to override. First, let's go ahead and select our corridor model. And before we access the section editor, let's navigate to a few of the setup tools. Let's first look at the View Edit options. And in here is where you define all the different settings for the section viewport that will be displayed. Let's set our grid here to No for the horizontal and for the vertical. This will make it a little bit easier to see the corridor model. notice that you can change any of the other settings that you see here. Let's change our default code set style to a view-edit, which will hollow out or hide the shape codes. Let's click OK. Next, let's check our viewport configuration, and let's make sure we set our layout to 2 horizontal, where we have the viewport 1 as plan and the viewport 2 as section. Click OK, and now we're ready to go. Click on the section editor tool, and as you can see, you get 2 viewports which define the top view as the plan and the bottom viewport as the section view. Notice the ribbon becomes a contextual ribbon, and we can go in here and select the different baselines and stationing we want to see. We're interested in the first baseline, and let's go ahead and click on this little browse button right here to kind of get ourselves started to put the section editor inside this view. We'll click on the view here, and now we're near the station we want to be. This is not an exact station value, so you'll notice here you can actually save this as an intermediate station, and Civil 3D will actually use this station as a modeling frequency. We can also just click the next button here, and we're now at an equal station interval. If we just peruse our model, we're just navigating along here. If you look in the plan view here, you'll see a station tracker. You can also select this and move this along the alignment to get it to a station you want to go to. Notice how it updates in the cross-section view automatically. As you're going through the review process, you're going to have edits that you want to make to your model. Civil 3D provides the parameter editor tool to make edits and override your corridor model. Let's say, for example, in this area here, we would like to actually override the default -2%, and we're going to super elevate the road to drain down to the right side here. So from station 12 plus 00, we want to start there. We want to actually have it drain here to a specific station range within this area where we're eventually going to have some sort of drainage catch basin of some sort. One of the other things that you can do with the zooming is if we zoom into an area, and let's say we want to make this actually a permanent way of zooming as we peruse the different stationing, you can click on this drop down here and set it to zoom to an offset and elevation instead. That way when you click next here or previous, notice how it stays in that station offset and elevation. So let's go ahead and change this. Let's navigate to the parameters editor, and in this palette here, you'll see that Civil 3D puts them into different categories defining right and left. So we're interested in the left side, and we can minimize the different parts here, which of course are the subassemblies defined in this area, and all we're interested in is the left lane. Scroll down to the default slope where it says -2%. Let's type in 2% instead. Notice how this station will update automatically. This is actually updating the corridor model. Notice a toggle has appeared that says you are overriding the default subassembly. Now, we want to apply this, of course, to multiple stations, so instead of having to do this manually, there's a tool here called Apply to a Station Range. Let's go ahead and click on it. Let's click on the Pick Station button here to actually define it within our alignment. We'll click on this viewport once, and we want to drain this through this transition area. So we'll go ahead and just snap to the endpoint of this line here, and that will be the modeling station. Click OK. To just verify that this has taken place, you can click the next button here to do so. Sometimes Civil 3D will not rebuild the corridor, and it's simply a matter of clicking on Update Corridor to update the corridor model. Note that if you were to rebuild the corridor model, this override would still override the default subassembly through this area. To remove this, you would simply toggle this off, and then it would remove it through that area where it would then go back to the default subassembly slope.